So now we're getting into specific triangle use, and that's where we're kind of going to be staying for the rest of this part of the unit over the next few days. So what I want to do to start with is basically how do we label a triangle? Okay, let's just start with two different types of triangles. The one is a right angle triangle, and the other one is a non-right angle triangle. Okay, so a right angle triangle, okay, what we can do is very simply, we can say, let's label some of the sides, okay? We'll label the sides. Well, this is what we do. If we have angles A, B, and C, what we have there is we have the opposite sides are always going to be the lower case letters, okay? Opposite sides are the lowercase letters of the angles, all right, in a right angle triangle. Okay, so we've got that listed there. If we were to have, let's say, a non-right triangle, again, we can label it A, B, C again. And again, we just take a look at the opposite side as A, opposite here would be B, opposite there would be C again. It's just a way that we identify the triangles themselves. Okay. Another way that we're going to be identifying triangles, okay, when we talk about, let's say in particular, a right angle triangle itself always has a hypotenuse. Okay, the hypotenuse is always opposite the right angle. But then we have two other names for the other sides. Okay, and they depend on what we're looking at. If we have an angle here, and what this symbol is theta, it's a Greek letter theta we use a lot, okay? What we do is we say, well, what is opposite the theta angle? We call it the opposite side length, okay? And then the one right beside the theta angle is called the adjacent side length. We're going to use those terms in our trig ratios, okay? So if I were to relabel this triangle, we know automatically the side opposite the right angle is the hypotenuse. Okay, it's going to stay like that. But if we now look at this angle and call it theta, well then the opposite side to that is now called the opposite. Okay, and the other side that it's attached to is called the adjacent side length. Okay, again, we're going to be using that in particular now when we start talking about the sine, cos, and tan of a specific angle. All right, the side length names change depending on what angle you're looking at. All right, what we're going to talk about now are the primary trig ratios. Primary trig ratios. All right. And there's three primary trig ratios. We talk about the sine of an angle, which is the opposite side length divided by the length of the hypotenuse. We have the cosine of an angle, which is the adjacent side length divided by the hypotenuse, the length of the hypotenuse. And finally, we have the tan or tangent of an angle, theta, which is the opposite side length to theta divided by the adjacent side length to theta. Okay? And basically we have to be able to use these, okay, in a variety of different situations. Okay? So let's say, for example, all right, our first example, we have a basic triangle. We have a right angle here. And what we want to do is we've got this length that's up at the top here. We talk about it as being, let's say it's just 10 meters long. All right. And we want to find out what the opposite side here is, or the other side here. I call it opposite. What I want is I'm going to know what this angle is here. I'm going to call that angle or label that angle as a 48-degree angle. Okay? what we need to do in here is recognize which one of the primary trig ratios we're going to use. Okay? How we do that, I'm going to start you off by saying, okay, what is given to us? Well, what's given to us is we have an angle, right? We have an angle. An angle's given to us. Theta is there. All right? So this is the angle that's given to us. All right? We also have to that angle the adjacent side length. That's given to us. All right? What is it that we need? Well, we need the opposite side. Okay? So we need the opposite side. And what I want you to do is then figure out, what do we use? Which one of these three things do we use? Which one of these three has the angle, adjacent, and the opposite side together? And so when you look at it, the angle is theta, there's adjacent, and there's opposite, right? If we've got that, then we can just say, oh, that's what we use, right? If you notice with all the others, what it says is if we can't color in all of these. Sine, we have an angle, right? We have opposite, or we need the opposite, but we don't have hypotenuse. Cos, there's an angle used. We have adjacent, but again, we're not looking for hypotenuse. All right? Tan is the only one where we have all three listed. So that's what we're going to use, all right, the tan of the angle, or tan theta itself. So tan theta, opposite over adjacent. All right? So here's how we do it. We say the tan of 48 degrees, we fill it in, is equal to the opposite, which is x, divided by 10. This is where we're using our ratios. This is where we're using, the fractions, the solving an equation. And so we want x ball by itself. It's divided by 10 here. So what we do is we multiply by 10 on both sides. So we end up with 10 times the tan of 48 degrees is equal to x. Okay? And at this point, we always go to our calculator and figure out what the answer is here. And you have to be able to use your calculator properly to get the right answer. So my calculator, I can go straight forward. I can put the 10 in, and then I multiply by the tan, and then I put in the 48 degrees, and I press equals, and I get 11.11 approximately. You need to be able to do that as well. Sometimes, in some calculators, if you're not getting that answer, you need to go backwards on your calculator. You need to put in the 48 first, then press tan, and it'll give you some decimal answer, and then multiply by 10, and then you'll end up with 11.11 in this one as well. Okay, that's the idea. I'll show you one more, and that should be enough for the video to get a good idea. If we have another example here, and I say, all right, we've got another right angle triangle. Okay, here's the right angle triangle there. We're looking at finding, we want to know what this angle is. Okay, so we don't know what it is. What we do know, however, is we know the length of the hypotenuse side. We'll make that at 17. And we know this vertical height, we'll call that at, let's say, 13 itself. So again, let's run through what we need to use here. Okay, if we label each side of the triangle, we know that's the hypotenuse. Since we're dealing with theta, that's the opposite, and this is the adjacent. Okay, so what are we given? We're given the hypotenuse, and we're given the adjacent. Okay, what is it that we need? Now in this question, we didn't have the opposite there. We just had theta as the unknown, and that's the angle. So we need the angle, or theta you can write down. Okay, so what do we use? Well, remember we've got hypotenuse, adjacent, and the angle here. If we go back up to our three things here, and maybe what I'll do is I'll just use a different color of the highlighter so we can make it a little bit stand out. I'll go with the red in this one. In each case, we're looking for the angle. Okay, there's the red. We're looking for the angle. Do we have the opposite? No, we have the hypotenuse. Do we have the adjacent? Yes, and the hypotenuse. Well, look, there it is right there. Okay, the only one that we have all three filled out for is what we need in this situation is cos. So that's an idea of how we can figure out what we're going to use. So in this case, we're going to use the cos of the angle itself because that is the adjacent over the hypotenuse. Okay, so we say cos theta equals adjacent over hypotenuse. Now here's the thing that we have to recall from our grade 10 work with the trig units. Okay, the opposite of cos, the opposite of sine, the opposite operation of tan is the inverse. Sine inverse, cos inverse, tan inverse. So what we do is we write that on the other side with a cos to the -1, and we say it's the cos inverse of 13 over 17 in this case. So you have to be able to figure this out in your calculator of how to calculate the inverse. In mine, I have to press the second function, okay, and then the cos button, because right above the cos button, I've got cos to the -1. And you should have the same thing there. What I do on this one is I say 13 divided by 17 inside of a set of brackets that it gives me. It may not give that to you, okay? I'm going to end up with approximately 40.12, okay, degrees. And that's what I get for an answer. If you don't get that when you go cos, cos inverse 13 over 17, what you might have to do is you might have to put 13 divided by 17. Press your equal button. And then do your second function cos so that you can calculate the cos inverse, and it'll automatically then go to the 40 degrees. However you have to deal with your calculator to get these answers, you need to figure that out, and you need to always use that calculator. Okay? Remember what you're going to be doing, what the order of basically putting in the equation themselves. Okay? You should be able to get to these questions now. All right, to do that, the last thing in basically solving a right triangle or solving a triangle just means to fill in all of the information that you don't know. All right, once you have two sides, if you have this side and this side, you calculate your last side with the Pythagorean theorem. And if you're calculating an angle, if you've got the 90 degrees in one angle, then you just use that 180 degrees minus the other two, right? The 90 degrees minus whatever that other angle is. Okay? Ask me questions if you need to.